Hello everyone, I'm Xiaogan. Okay, we'll guide you through creating this plugin first. We'll just skip this part. After skipping, check the file count and template and make sure it compiles successfully. Okay, we've created it. Now let me show you these files. These 5 header files. This one is the original, right? We can delete it, but let's leave it for now. Let's not touch it yet. Okay, I can see these header files look like this. We haven't written anything in them. So let's compare. But right now, it definitely won't compile because it shows a red line because it can't find this file. Because on our end, the include path for this also needs to be changed. So here we are in the Build.cs file. Let's start doing some work. First, delete these 2. And then we need to make it change the include path for this prelite. Let's modify the path. Okay. Let me see. Writing it this way should be fine. Let's check how our previous plugin was written. For example, this plugin, this path is written like this. Let's bring that over. Then here we don't really need it to include subsystem because this is a singleton we use internally. So we don't really need it here. We'll just have it include this BP library and these type of hours. Now let's try to compile it. At this point, compilation should be fine. Okay, good. So after compilation is done here, let's go ahead and add which modules we need to use. First, we need to remove the engine. We must remove the engine. After removing the engine, we definitely need to use this midwife. Let me think. This midwife doesn't seem necessary either. This midwife probably doesn't need this midwife either. Right, no need for a midwife. Then we mainly just need to use the 2 modules, socket and leader working. Leader working already includes socket. Okay. So after we finish adding this, we need to get rid of this BP library. The reason for getting rid of it is quite simple. Because we can't let it remember. We need to remember it as a UObject. Yay, okay. Because we cannot let it be remembered as a library. Because library belongs to the engine, okay, then we let it compile again. Because we must ensure that our stuff must compile successfully before we actually start carrying it. If it doesn't even compile and you start carrying it, it will be more troublesome to troubleshoot errors. Okay, because there is no engine, so the case meter cannot include it either. Then we call a mimino call me over here. Okay, let's compile it here again. No problem. Let's just remove this method. We won't use this method, okay? Then we'll start writing our code formally. First, let's add the log. For this log, we'll write it here. Let's first declare its header file. Okay, let's modify this again. Okay, then let's declare its specific definition. Paste this over. It should be the same. Okay, then you can see that these are all red lines, right? If you feel uncomfortable, you can refresh the project. Okay, we will refresh the project here. You can also refresh yours. Otherwise, when you include this module later, if you haven't refreshed the project, some things might not be properly imported. Okay, then we will just give the definition here. This is also quite simple. Then here, first we give the definition of our entire email. It has these states. Then how to use this specific state when we write the code. Everyone is fine. Then because of our definition, it should have been explained to everyone earlier. The reflection file here, we need to edit. Okay, then we need to prepare a delegate here. This delegate is also quite simple. That is, after we finish, we only have 1 delegate. Just success and failure. Success means nothing if completed. Actually, if it fails, you need to specify which state failed, whether it's the wrong password, and so on. So it's a simple dynamic single cast delegate. 3 parameters. As you can see, there are 3 parameters. This GUID delegate is very familiar. This method uses an enumeration. On our end, we can just use strings. And here, the first piece of information is our key information. As for this key information, it is also relatively simple. That is, it is about our email and this authentication token, such a key. Okay, this is because we need to add a macro here. Let's add a macro here. Because this is quite obvious. If you want to use it in C++ without adding this macro, others won't be able to use it in C++. It can only be used in Blueprint. Okay, next, it is about the specific information we want to send. As for this information, it is actually also relatively simple. So these are from name from mail to mail and to mail, then this subject and the specific content. Then there is a detail here. I need to explain to everyone. Okay, we have this method called toastGene, right? We mainly need to write out this toastGene method because we are not using a connector here. Because its communication is not based on a connector. We need to concatenate the entire message. So how should we concatenate this method? Let's define a string to receive it. Then we return this without modification. When concatenating it, actually, we use a point for format to concatenate it, okay? So actually it's like this. Its format is 1. In here there is an S. Here there is another S. This is the specific email address. This is the email alias. And this is the recipient alias. The recipient's email address. Yes, it should be like this. And here is the subject. Then the specific information. And this shoe cylinder. To shoe cylinder 2. It is used for segmenting and splitting. Things like this are generally agreed upon by the server. The server decides how to split it. You split it on the server side. Then if you can, just add things arbitrarily, because after you add them, if you write too many of these shoe cylinders, 2 shoe cylinders, the cut result will be incorrect. It will report this kind of data cutting, anomaly information, giving you errors. This is something I need to pay attention to. Okay, then for these 2 structs, we'll just put them together. We put them together as 2 parameters. We'll complete the setup all at once in Blueprint. Okay, over here we'll move this down. Okay, after comparing such a struct, we can compile it here. To get it to compile successfully, this should definitely be fine. Because we haven't actually written much. Just define a struct. Next, let's go ahead and present this method to everyone. Let's move forward. This time we'll just go ahead. This uCrossBody actually is already deprecated. It's deprecated. Actually, it's best not to use uCrossBody anymore. Don't use this anymore. Okay, so here, read pattern add a countdown rat to it. Because in this place, if we want other places to be able to use it, we give it a countdown rat. Then after we have uCrossBody, we don't need to write this constructor anymore. Okay, and this uCrossBody, it will do a bad thing. That is its default permission. It will give a public. This is a very bad thing. So everyone here, sometimes there are some small details. This should have been mentioned earlier as well. Okay, here we make it public. Then we will take these methods and paste them one by one for everyone. I'll paste them out and explain what each method does. The first method, obviously, is for sending these requests, but we haven't written anything yet. We're just writing out the methods. And here, we need to include this type because we are using the data structure inside it. Right, okay, once we have this type, we take this information. So when we make an application, we need to fill in this information. Then we ask it to provide a callback proxy. Then we output a GUID. Okay, this is the first method. It's relatively simple. The second method is to check how many. Reason because we might be making many such requests. We don't want. Because every time you send a request, it actually consumes a significant amount of CPU resources. So we want to take a look at whether we have many. So this is a potential method that can be used. And it's relatively simple. And then after we have this GUID, we can query this method to see exactly what state this method's applied action. The action applied by the method is currently in. You will find that this side is out. It might be gone. One person has already completed it. So this side provides a boolean. Actually, you can combine them together. This method is not our focus either. It's just a simple CRUD operation. To ensure this thing, it is complete. That is, it has a beginning and an end. Has complete data. Then this place can also remove it. Remove, and then this place is a release, all of these except actions. These methods are actually potential methods, not the focus of this chapter. We mainly focus on this one. Next, let's create all these methods in one go. Okay, it should be fine at this point, because we can just keep everything as default. Because we can't write it yet. We'll write the actual logic into our subsystem and into our runnable. Now let's write our subsystem. And this subsystem is not a real subsystem. First of all, we definitely need to include this type. And because it's not a real subsystem, we don't need to include this. Include what we call reflection files and such. Also, this subsystem of ours doesn't need to be exported. Because we use it internally, we don't need others to use it. We hope all our methods go through Blueprint. Then we can just call this subsystem by this name. We don't need to write that dirty body anymore. Then, we also write out its constructor and destructor. Actually, you could just remove these constructors here and it would be fine. Because this thing is only allowed for our own use. Then, once we have it, we prepare two methods. Actually, these two methods are for getting our current system. This is a singleton approach. After getting the current system, destroy this system. Then I definitely need to prepare a pointer. Prepare such a pointer. Okay. These few methods. Now we put these two things, create all these methods. Let me look at this place. Okay, then at this point, we need to give our object to it. It is static, right? So we need to declare it inside and outside. Because its life cycle needs to be earlier. So in this place, we declare this inside and outside. Subsystem, we'll just leave it there. This method means we don't need to. It's equivalent to us declaring it in advance. Let me check where the error is. Let's see if there's any reason. The reason for this error is very simple. We are missing a semicolon here. This approach, this type is more likely to be missing. I checked it. Because it kept prompting me with this reason, it should be missing a semicolon. This kind of problem is quite common. I also looked for a while. We can just add it back like this. Because it's missing a semicolon, it cannot recognize this. What exactly is the situation with this class? Actually, sometimes we can add a couple more line breaks here, because this is the end of the file. And after doing this, we will then make a declaration outside the class here. We'll just walk it out here. This is taking a shortcut. Actually, you could use our previous approach. We could also do it right here. But the advantage of writing it this way is that we don't have to worry about this thing. So that's how it is. Okay. So after we do this here, remember this thing. Writing it this way is actually fine. It's not a big problem. We just need to return this. If it gets released, we simply check whether this pointer exists. If it exists, we need to let it release. Okay, let's ignore this for now. Okay, let's first improve this singleton. If it exists, release it. Now we have this object. It should compile successfully now. Okay, this blue underline seems to be because of a spell check. I'll disable the spell check in a moment. Then here, if we follow a standard workflow specification, actually, you should do some work here in the module section because we have resource requests here. So we hope that for the resources, we also need to release them in a timely manner. Here we just need to include the header file. Okay, with that, we just need to get it here. Take a look at the subsystem. Let it get it. Okay, after we get it this way, then we can call the release here. So for the files in this module, we generally use them like this. It's because we've found many complex plugins and projects. Sometimes he doesn't want the user to adjust these elemental interfaces. He can go to this place to adjust them. Actually, we sometimes like to call this method distory. Called the distory. This is called git. This is also a personal habit. We can name it whatever we like. Okay, let's arrange it. Let's compile it again. It should be fine everywhere. Then next, we need to write our save action. Okay, we'll write it in the next few lessons. We'll stop here for this lesson.